Okay, guys, we had a question on how thick the chamber was after we machined it out. So, the simplest way I could think of is just to grab with a pair of calipers. I don't know if you guys can see that. Let's measure that. About 270 thousandths. What's interesting is this part of the chamber is actually solid. That's why it has holes at the very bottom for coolant water around the plug. These go right through. Okay. The rest of this is solid. This can all be machined out without really worrying about it. And without, you don't have to worry about that cracking that. It's, like I said, I've been doing it for decades, and I've never had one crack like that. I did some more work on the port themselves. I took out some metal around the bolt between the two intake ports, and it actually gave me a loss. Okay, not much of a loss. This was yesterday's. This is today's, and you can just look down the column, and I put either pluses or minuses. It actually lost a little bit everywhere, opening that bolt up a little bit. Now, is that big a deal? Not really, because it'll probably change when I finish the valve job. But Charlie has a tendency to get flow blind, which means I'm searching for real high flow numbers, and it may be a waste of time. So I looked up what Larry Moe was getting, and I was completely blown away. I mean, yeah, he's only doing it with 160, I think it was 163 cc port, because it's super stock. So it's got to stay whatever it originally was. And most small block Chevy ports are like 156. So that's almost 10 cc's. That's about right. And I took his flows, and I compared them to what I'm getting. Now, he's also doing it with a smaller valve. He's doing it with 194. Let me tell you, Larry is spectacular. I actually invited him to come and take a look at what I'm doing here and interact. I wrote to him on Speed Talk. I don't know if he saw it or not. But if you take a look, right, I'm doing good. I'm doing good. I'm doing pretty good. I mean, yeah, I'm sure I have a bigger port, and I have a bigger valve. So, okay, but take a look at the power he's making. He's making 585 horsepower with those flows. That's insane. And he talked about how fast the port was at specific spots, because I know that's a critical thing. And he lost a tremendous amount of horsepower in another port that was similar, and it was fast in a couple spots. So I decided to take some other airflows. The ones that I have circled are from the last flow. Okay? Pinch is relatively slow compared to the darts, right? The roof is definitely slow compared to the darts. Relatively even too, right? These are relatively even top and bottom. These are relatively even from side to side. And take a look at the short side radius, which is 378, 370, 366. That's pretty darn even across the short side radius. So I'm wondering if I really need to do anything else to these at this point. I calculated up the pinch. and the pinch calculates up to 274 CFM. That shouldn't be holding me back at this point. I'm only at 255, and that's at 800 lift, right? So I think I'm going to finish cleaning these up, get all balls equalized, then move on to the other head, do the same. Then I'm going to get my honing tank in a couple days. I'm going to go over the guides, put a better valve job on, and see where I am. The other thing I wanted to show you tonight is a speed control demo. That's the potentiometer for it, right? The potentiometer, you can vary it from 0, right, to 999, okay? I talked about that in one of my first videos. Now, it's a SCR controlled drive for DC motors. Built by KB Electronics. It's for industrial use. I think it's good for a half a horsepower. It really should be an electrical box, because that's all hot. Okay, let me set this up. I don't want to show you how variable that really is. Okay, I took the bit out so I can show you guys. Take a look at how slow. Now, you have to remember, right? The motor in here is very similar to the motor in a pistol drill. They call it a universal motor, really. It's got commutator, it's got brushes. Okay, universal motor doesn't care what kind of current it has going through it. So, literally, right now, speed is set for 0. I can set it for 1. I can set it for less than 1. All right, I can go 10, 20, 30, 40, and it'll start turning. Okay, and then I can go up 100. 140 is about what my Nikita's like. My DeWalt's more like 240, 250, right? And that's the maximum speed of the grinder, which this grinder is 25,000, which is ridiculous. You should never be using 25,000, okay? Now, I'm not sure if you guys can see. I may not have been holding that where you guys could see. But it's a really nice piece. And the part that I really like about it is it's DC. Okay, so what does that mean, Charlie? Well, it's taking the AC signal and it's chopping it into DC pulses. So when you send the pulse through the winding, you get a really big magnetic field, which means the torque is fantastic compared to like a rheostat that you would reduce the voltage. Completely different. FYI, KB doesn't send me any money, but you know what? It's a really good piece. Not exactly cheap. You'll never wear it out, and it's good for about a half a horsepower. So it covers all electric grinders you could possibly want to use. Thanks a lot, guys. I almost forgot. I wanted to show you guys. Remember I was talking about I changed the texture and I was able to get more accurate readings. Well, right now I have this actually in scan mode. Scan mode's kind of cool because you get way faster readings with scan mode. Oh man, I had this was the bowl that had the machined spot still in it because it was so thin. And now that I changed the texture, I was able to get. Come on, gotta have plenty of goo on it, otherwise you won't get a good signal through it. That isn't working at all. The thin spot was right here. Okay, now it's telling me I got 116, 111. All right. Before was much less than that. Okay, and you can see by the bar graph that I've got a good signal on it. I don't know if a lot of people know how this works, but it's a kind of a cool piece. The transducer actually has two different halves, right? It sends a signal out one side through the iron or aluminum, reflects back, and it measures the time it takes to go through that. And when you calibrate it, okay, I have a special piece of old 289 head that I use as my calibration piece. Should I get something better? Maybe. Okay. Come on. You gotta give me a hard time. I have a feeling this battery's starting to go dead. Batteries, because this is what happens when the batteries start to go dead. You don't get, it doesn't pick up where it should be. It's telling me it's 132, but I know that's not right. Should always put new batteries in when you're going to go do a demo with it. Let's restart it. Okay, it should be about 114, 118. Okay. Yeah. All right, guys. Thanks a lot.